In the 1920s, long before the technologies and advancements of today's construction industry, a scheme was conceived to build an impossible bridge across the Golden Gate Strait in California. Today that structure remains one of the world's most famous landmarks, but to truly appreciate the magnitude of this achievement, you need to understand the bridge's story. The Golden Gate Strait is a mile-wide channel between San Francisco Bay and the Pacific Ocean. Many of Northern California's waterways and mountain slopes run into San Francisco Bay and out to the ocean through this channel, generating fast-flowing, treacherous water. Up to the 1920s, before the existence of the bridge, the only way to cross the channel without taking an extended drive around the bay was by ferry. With the rise of cars and the growth of San Francisco during the boom years, some 2.5 car trips a year were being made across the water by 1929. The congestion led to growing calls for a bridge to be attempted across the gap. Many felt such a feat was impossible. The channel's width, combined with a depth of over 372 feet, which is about 113 meters, and the harsh environmental conditions were seen by many as too great to overcome. The city turned to the renowned bridge engineer Joseph Strauss to consider the feasibility of such a scheme. Strauss had a high pedigree in developing bridges but was infamously difficult to work with and had a reputation for creating unattractive designs. His first proposal was widely disliked, and the city's authorities insisted that he could only proceed if he accepted design input from others. That input came from Leon Moisseiff, Irving Morrow and Charles Alton Ellis, and led to the development of the bridge as we know it today. Despite public support, gaining approval for the bridge was not easy. The Golden Gate Bridge District, a holding company established to construct and operate the bridge, faced opposition on a number of fronts. First, they had to contend with the Southern Pacific Railroad Company, who operated the highly profitable ferry service. The operator filed over 2,300 legal disputes in an attempt to prevent the bridge proceeding. Then they had to deal with the U.S. Department of War, as it was then known. They feared enemy planes bombing the bridge and collapsing it into the strait, trapping Navy ships in the bay. They also voiced concerns about vessels colliding with the bridge during rough weather or in San Francisco's infamous fog. The Department of War even pushed for the bridge to be painted black with yellow stripes to make it highly visible. Eventually, opposition gave way and plans to develop the bridge proceeded. But just as that milestone had been reached, the financial crash and Great Depression hit. Government funding evaporated and the bridge's future looked very uncertain. Determined to boost their economy with all the benefits that the bridge could bring, the city's authorities took matters into their own hands. To secure funding, they proposed a bond measure secured against the properties of their citizens in San Francisco and in the counties north of the bay. In a remarkable step, this decision was put to a referendum and those Californians decided to proceed with the bond, despite the widespread concerns about the bridge's feasibility. The bridge's $35 million cost and associated the finance fees were only paid off in 1971. This historic vote combined with an initial $5 million credit line from the founder of the Bank of America enabled construction works to commence. For all the struggle that had gone in up to this point, the hardest days still lay ahead. Construction began in January 1933 with the erection of the bridge's towers. Each of these structures weighs 22,000 tons and stands 746 feet tall, about 227 meters above the waters of the bay. They carry the entire weight of the bridge. The first step was to create footings and erect the North Tower on the banks of Marin County. Construction of the South Tower out in the waters of the strait was far more challenging. First, the team built a temporary pier 1,100 feet, or 335 meters, out into the ocean. This pier was destroyed twice during the works, once by a storm and again by a steamer ship traveling in the fog. At the end of the pier, pilot bombs were dropped down shafts to break up the rock under the seabed. Seagulls swarmed over this operation as stunned fish floated to the surface. With the bedrock loosened, the area was dredged before the first underwater concrete pour. The area was then pumped out, and the remainder of the concrete was dry poured. Simultaneously, the concrete anchorages that the suspension cables would connect to were cast on either bank. The scale of concrete being poured across the bridge site led to an on-site mixing plant being established. With the southern footing in place, the steel South Tower was erected. The next step was to suspend cables from the bridge, a process which began in the summer of 1935. The cables used are in fact formed of many individual wires, 27,572 wires to be precise, totaling some 80,000 miles in length, enough to circle the globe 3 times over. With shipping lanes closed, the first wires were dragged across the bay by a Coast Guard vessel and lifted by crane into the 150-ton curved cable cradles on top of each tower. A mid-span working platform was then slid across. With this successfully achieved, the painstaking process of bundling and draping strands of wire back and forth across the bridge began. Those at the top of towers worked for months in 45 miles per hour winds, 746 feet above the water. Despite the hostile environment, productivity was high, and in one record-breaking shift a gang managed to spin 1,000 miles of wire across the strait. As each wire crossed, they were tightened at their opposing end, eventually forming the bridge's 2 main cables, each 3 feet wide in diameter. Wooden pallets were then hung beneath the cables, creating a catwalk for workers to weave, compact and bond the wires before painting them to create a watertight seal. With the main cables in place, smaller vertical cables were dropped down towards the water. Steel trusses were then attached to them, creating the deck for the concrete roadway to be poured on. Throughout the construction process, many workers fell from the bridge. A fall to the water from the road deck was fatal in most instances, as impact speeds reached 75 miles per hour. Thanks to a then innovative safety net, many construction workers who fell were saved from hitting the water and became members of what was dubbed the Halfway to Hell Club. Tragedy struck in February 1937 when a paving machine fell into the net, taking a number of workers with it. The net collapsed under the weight of the machinery and 10 people were killed in the incident. As construction progressed, so too did the debate around what color the bridge should be painted. It was the bridge's orange steel primer that struck a chord with the public and suited the Department of War's requirements for visibility. This shade is actually known as International Orange, a standout tone that is also used on NASA astronauts and American footballs. Just 4 years after construction work started and with 600,000 steel rivets in place, the bridge was complete. It opened on the 27th of May 1937 with a pedestrian walkover day. Cars followed 24 hours later. Traffic was stopped and the walkover day repeated for the bridge's 50th anniversary in 1987. However, serious overcrowding occurred and the bridge deflected by 10 feet, flattening out under the weight of the crowd. This extremely dangerous incident has led officials to commemorate anniversaries in different ways ever since. The bridge has been a huge cultural and economic success since its completion. Over 2 billion cars have now crossed the deck, and the Golden Gate has gone on to become an American icon, synonymous with the city of San Francisco. Such status has led to increased security, particularly in the post-9/11 era. Steps have also been taken to better protect the bridge from seismic activity, especially as technology and research in this area has moved on from 1930s understanding. The bridge sits between the San Andreas and Hayward fault lines and is at risk of high-magnitude quakes. Energy-dissipating devices have been subtly retrofitted and the towers supporting the approach ramps have been completely replaced. Maintenance of the bridge is an ongoing task and falls to a team of 110 full-time personnel who look after every aspect. In maintenance terms, the bridge is very similar to an offshore oil platform. It must contend with ocean climates and the onslaught of the elements this entails. Repainting is done by specific areas, based on corrosion monitoring, whilst an on-site steel fabrication shop is able to create replacement components. Larger-scale refits have taken place, including a complete replacement of the suspension ropes in the 1970s and a new lighter steel road deck in the 80s. Now 80 years old, the bridge remains one of the single most important elements of U.S. road infrastructure. A key piece of cultural and construction heritage and an iconic symbol of what human engineers are truly capable of.